This video specifically talks about if you have a linear graph, what do you need to look for to find the equation, to create a table of values, and figure out what the situation might be. So for all linear functions, we need two pieces of information, and then we can go ahead and write the equation, or if we have the equation, we can find those two pieces of information. The two pieces of information that we need are the starting place, which is the y-intercept. It's always where x is 0. If we're talking about a sequence like tile patterns, it's always figure 0. We can talk about the 0 term. But it's always going to be in your table, it's going to be when x is 0. And the slope talks about how fast the growth is. So it's always going to be rise over run. How fast it goes up for how far it goes over, or how fast it goes down for how far it goes over. How much is being added or subtracted each time. Those are all ways of thinking about the slope. But once we have the slope and the y-intercept, then we can put it in the equation. So when you have a graph, you have to find the two pieces of information that we need. We need the slope and we need the y-intercept, right? We need those two pieces of information. And the graph, it's pretty easy to find. I'm going to blow the graph up for a second. And with the graph, you need two pieces of information. One is the slope. In this case, there is no change in y. It stays constantly without rising or dropping. And then there is no change in x either, but we can just talk about that being infinity. So the slope for this one is 0. And the y-intercept, where x is 0, is going to be at 0, 4. So we have the two pieces of information that we need. So we can go ahead and, for one, easily, we can go ahead and start making a table. There's two ways of making the table. We can start, here's our x and our y. You can just read, points off of the table. So like here's 0, 4. Let me use a highlighter for this. Here, 0, 4 is right there. And then that's one of the points. And we can read, for example, 4, 4. That's a point on the table, right? Or you can go ahead and use what you know about how it's growing. Well, this one is growing by adding 0 each time. So you can go ahead and build that equation build that table by adding 0 each time. 3, 0, 3, 4, plus 0. And I could put 30 in there and still be at 4. So you can build the table by pulling points from the graph, or you can build the table by starting at one of the points and using the slope. And then we can go ahead and do what we need to do in terms of the equation. We know that the slope is 0, and the y-intercept in this case is 4. So we can go ahead and just fill in our template. M is always the slope, so we're going to go ahead and put a 0 there, and then the y-intercept is 4. So this is a special situation, this horizontal line. Since the slope is 0, you can either write it the way we just did, or you can go ahead and write it as y equals 4. So if you just have a y equals number, then we're talking about a horizontal line that goes through that number. Now, sometimes I'm going to ask you to make up a situation that might be true for the graph and the table that you have. I've come up with two situations that might make sense. The first one is x is the number of minutes, and I think it's actually hours, but the number of minutes after my car broke down, and y is the number of miles from home. So my car broke down 4 miles from home. I didn't go any further than that. I'm still waiting for the AAA or something like that. And another situation, and notice when I talk about the situations, I tell you what x stands for in each situation. So in the second situation, x is going to stand for the number of days after my birthday, and y is the number of dollars. And so So y equals 4 because I had $4 on my birthday, and then I haven't spent any money, so y is going to stay as 4. So here's another example. And so one of the things, this was the one that you had on your foldable. It's just a little prettier. And so if it's already done, you can go ahead and just check with what I have to say. And if it's not already done, I would do it first and then check against mine. So I'm going to do this one a lot faster. So first we're going to look at what we know about the graph. And there's a couple of things that we can look at. One is we want to find the y-intercept, which is 0, 2. And then I'm going to go ahead and make a slope triangle right here. And I get a slope of 4 for every 2. And remember that works out to be simplified 2 for every 1, because I can go ahead and look at that giant 1 that we can use to divide. 4 divided by 2 is 2. So the slope can be talked about as 2, or 2 over 1, or 4 over 2, or 8 over 4. They're all exactly the same. So now we have the two pieces of information that we have. We can write the equation now. We can write the table of values now. It depends on what the situation asks us to do. I'm going to go ahead and just create my table of values. I know that one of my points is 0, 2, so I can go ahead and start my table there. And then I can read points off the graph. I've got a point at 1, 4. But also, I know that it's growing by 2 each time. So I could continue my table by going and following the pattern. Those points are also going to be right there. So here's 3, 8 that I just wrote by following the pattern. Here's 3, 8 on the graph as well. They all work together. And then we're going to go ahead and fill in the information. We already know the slope is 2. You can write it as 4 over 2. You can write it as 8 over 4. The y-intercept is also at 2. So we have y equals 2x plus 2. Let's look at some situations that might make sense. So y equals 2x plus 2. We can talk about what would make sense to have a y-intercept of 2 and growing by 2 each time. So one of the things I thought about was, how about a tree that's planted when it was 2 feet tall and it grows 2 feet every year? So in this case, the x stands for the number of years, and y is the number of feet tall it is. And the growth is the slope, and the y-intercept is the fact that it was planted at 2 feet. Same exact equation, different situation. Anna has a thing for stuffed animals and buys herself 2 every week. She already had 2 from her sweet boyfriend. So the equation here, this 2, that is our y-intercept, talks for the 2 that she had from her boyfriend, which is the y-intercept. And this 2 is the 2 she buys for herself each time. So we have to be real careful when we're thinking of situations that we know what x stands for. This one, by the way, I just did this wrong. This is the y. My word, I just realized that I flipped these around. X stands for the number of weeks, and y stands for the total number of stuffed animals. Whoops, my bad.